Hello friends, in today's question, a bow of mass m suspended by a string of length L1 is given a minimum velocity required to complete a full circle in the vertical plane. At the highest point, it collides elastically with another bob of mass m suspended by a string of length L2, which is initially at rest. Both strings are massless and inextensible. If the second bob after collision acquires the minimum speed required to complete a full circle in the vertical plane, the ratio of L1 and L2. So we have two bobs, both having same mass m, and let us suppose this is a bob of mass m, and let us suppose its position is A and its length is given as L1, length of the string, and it is going to rotate, and it's at the highest point it is going to strike another bob whose mass is also m, and let us suppose that is called as B, and this bob A will strike the bob B elastically such that bob B also makes a circle in the vertical plane like this, and there is a string which is connected to this bob B and whose length is given as L2. So we are supposed to find out the ratio of L1 and L2. The mass of both the bobs is given as m. So we already know that the minimum initial velocity which is required by bob A to complete a full circle, let us suppose that is given as u1, and u1 will be equal to square root of 5g and the length of the string, in this case that is L1, or we can say the radius of circle, which will be L1. So we can write it here. The minimum initial velocity of the bob A to complete full circle, let us suppose that is given as u1, and that will be equal to 5g and radius of the circle, which will be L1, and it is square root. Now this bob A is going to make an elastic collision with bob B, this bob A makes an elastic collision with bob B, and we say that the velocity of bob A when it's collide with bob B is given as v1. The velocity of bob A when it collides with bob B is given as v1, and we can use the equation of kinematics to find out v1. We can say v1 square is equal to u1 square plus 2as, where s will be total distance, that is twice of L1, and our A will be equal to minus of g. So from here we can find out that our v1 square is equal to u1, we already know, is given as 5gl1, and we have minus, this will be 4gl1. So we can say that v1 will be equal to square root of gl1. And we also assume that the velocity of bob B after the collision is given as u2. You can say after the collision the velocity of bob B is given as u2. Now we can use the conservation of momentum. You can say by conservation of momentum, we can get equation as mv1 is equal to mu2, mass is same, so m and m cancels out, so we can say our u2 is equal to v1, which is equal to square root of gl1. So it means the initial velocity of bob B is square root of gl1. From here we can say, thus the initial velocity of bob B is equal to u2, which is equal to square root of gl1. Now in the question it is said that if the second bob after collision acquires the minimum speed required to complete full circle, that means bob B is also able to complete the full circle. You can say bob B also completes the full circle, and we already know that initial velocity which is required to complete the full circle is given by 5g and the radius, in this case that will be L2. Therefore initial velocity required to complete full circle for bob B will be equal to square root of 5g and L2. And let us suppose this is given as V2. And let us call this equation number 1 and this equation number 2. Now equation number 1 is also initial velocity of bob B, and equation 2 is also the minimum initial velocity. Okay, so we can write here minimum initial velocity. So both will be equal. From here we can say equations 1 and 2 both are initial velocities of bob B. Therefore equation 1 is equal to equation 2. So we can equate equation 1 and 2. You can say from here square root of GL1 is equal to square root of 5GL2. And from here we get the ratio of L1 upon L2 is equal to 5. So that was the requirement to find out the ratio of L1 and L2, which is equal to 5. This is our final answer. Thank you.